Labs, and for the last 4 years he's been teaching Puppet, and he's been integrating cool things into Puppet. So take it away, Dan.
Great. Well, thanks. Really feels good to see so many people coming out to hear me talk and give what's going to be a somewhat theoretical presentation about Puppet. So what I'm going to be talking about is thinking about Puppet, but we're going to really talk about the internal architecture of Puppet and really how things work under the covers, so that we can map that to an understanding of how Puppet could be applied itself to be an actual orchestration framework. So specifically looking at Puppet, which has traditionally been very node-centric, make this node this, and understanding, can we use the same principles and behaviors to say, ensure an application stack exists against something like an infrastructure as a service provider. And then it'll be a somewhat honest presentation talking about reasons that it makes sense, reasons maybe that it doesn't make sense. So a little bit about me, just contact stuff. I have various email and the same ID, BodhiPD, on Twitter, on Freenode, pretty much everywhere. It's also my email address on everything that's not work related. So as you mentioned, I'm Dan Bodhi, and I have kind of a bit of an odd job at Puppet Labs. I'm fairly technical, but I also work more or less for marketing. And I have a job where I can work on things that are interesting, provided that they're interesting enough that I can write about them and speak about them, so that we can measure interest on the website. Right, to say that we know that these kinds of experiments and these kinds of concepts, which are somewhat cutting edge, are actually interesting. By being able to write about those things and then working closely with marketing to actually see, do people care? Right? Is this something that makes sense for us to focus on in the future? And I'm going to be talking about something that I've been working on for the last few months, which is just trying to think about how Puppet does or doesn't work, or what features are required for managing application stacks, or for just managing infrastructure in general. So this is my fun little logo, which I'm going to keep on having fun with until branding or marketing finally shuts me down, which is inevitable. The great thing about this is it's actually made with OmniGraffle, which is probably the worst graphics editing tool you could possibly pick, but it's good fun. This is my Puppet logo, and I have, embarrassingly enough, logos for all of our products that I've invented myself for fun. You got to do something. This is whenever your job is to speak, I can actually rationale time to work on stuff like this, which is good fun. So I'm going to start with a bit of an overview of Puppet, and this is my Puppet at 10,000 feet picture. Really, if we think of what Puppet does and what people are using Puppet for, it's to ensure consistency of how we assign roles to machines, right? You would have Puppet modules, which is the content that's used to describe how things should be configured, or that may be deployed to a master. And you're basically saying that all my Tomcat servers should look more or less the same, all my database servers should look more or less the same, right? So that the complexity of configuration is moved away from the node level and actually to the complexity of roles. Right, so you can say, I may have 10,000 nodes, but I may only have 11 roles. Right, so a tool like Puppet moves the complexity to the specification of the role, as opposed to having to worry about things like how many instances I'm actually managing. Slight oversimplification for people giving me brazen eyebrows. And the way that we do this is with a construct in Puppet that we call resources. And resources in Puppet are just the basic building blocks that we use in order to describe state. And I'm going to give just a very basic example of what a resource might look like. And again, they just describe the configuration of things, right? And traditionally, those things have been confined to the system that we're managing. And we're going to talk a little bit more about what other kinds of things can we manage and how would that work. So if we look at a specification like this, a user named Dan should exist, and it should have this shell, right? And in general, all the constructs in our resources kind of follow this of, it's a specification of what the state of something should be, right? Here we're describing that the state on a system is that it should have this specific element that's described in this certain way. So the way that we do this is with something called properties in Puppet. And it's not just that we are using this to describe a specific or a discrete element that needs to be configured, but we can also use it to describe the specific attributes of that element. And we'll look at some of the kind of intricacies of this, but it's more or less that Puppet's a framework where you specify getters and setters for all these elements. So at its core, Puppet's a system that you can specify how do we retrieve the current values of these things. And obviously, a user on a system, of course all of us know it can exist, right? We can use various tools to query, does it exist? Right? The other part for each property is determining how we can actually achieve that state as described with the resource. Right? Clearly we can do things like user add, or various commands across other distros to ensure that the user doesn't indeed exist. And shell is something that we can set as an initial state of a user, but it's also something that we can query from a user that exists. And that's really how we define what is a property. Right? A property is something that we can query, and then we can also remediate to a new state. Right? We can even transition the state of a property for an existing user between states. And really, at its core, this is fundamentally what Puppet is a way to describe these things in a discrete configuration language, and then it has an API for implementing essentially just getters and setters of how do we get things, how do we set things. So as I mentioned before, whenever we think about properties, and as I mentioned, ensure is a special property that maps existence. All properties are really just implemented as basic getters and setters, right? Can we get the current state of this thing, and then can we converge to a desired state? And for the most part, if we think about higher level constructs that we use to manage infrastructure, I think that it's pretty obvious that we can implement getters and setters for those things. Right? In general, we can say, I would like a virtual machine instance to exist against my infrastructure as a service endpoint API. Right? Does this thing already exist? And then make this thing exist. And also for components that already exist, if we query that something exists, it's easy to describe the states of those things, provided that the transition of those states is supported by the infrastructure as a service endpoint APIs. For example, if you support, modifying, expanding the amount of memory or attaching a local disk for instances that exist, and those are actually things that can easily be implemented as properties using Puppet's normal API and just implementing the getters and setters for those things. So I'm going to talk a little bit about Puppet's model and specifically the features that we get because of Puppet's model. And I've already talked about a fundamental principle of that, which is this idea of properties and this idea of how we implement the actual getters and setters that relate to how those properties are actually managed on the underlying system. So, with Puppet, we always have this description of what is the state that I want something to be in that maps to some reality. And it maps to that reality through the property getters and setters, which I was just talking about in the previous slides. So we always say, I describe that some state should exist, right? I describe that, for this example, that a package with the name get should be set to exist. Or as I mentioned before, ensure is a special property used to manage the existence state of things in Puppet. So looking at the getters, we have various getters that can be used to retrieve the current state per property, right? So in this case, the actual setters are implemented on what are called the providers, where multiple providers can be implemented for a single type. So you can think of type as the interface, right? So this is a type of package, but the implementation of those actual getters and setters is the provider. And here we can see an example of what the underlying implementation may look like of multiple providers for a single package type. Right, so the first step is we've described some state. The first step is we retrieve the actual current state, right? And being mindful of, the next part, which is, are those things actually the same? So Puppet always does this internal comparison, which you can override, but in general people don't. So so that all you really have to specify is the getters, and Puppet uses this to achieve what's called idempotency, which is a fancy math term that we probably beat the hell out of, that basically means that you can rerun over and over and over again, right? And Puppet will only actually make changes that it needs to make because of this, because we always have this conditional check of first to make sure that I should do something, meaning that the states don't align before I actually do something. And I think that when I go and talk to our customers about things related to using Puppet for managing application stacks or managing combinations of network configuration and application stack configuration, I think this is one of the characteristics that actually gets people excited. You can start to think of kind of a different paradigm shift of specifying a full application stack which might consist of VLANs and firewalls and virtual machines, and then rerunning in order to make a determination of does it match the state as I've described. Right, so to do this comparison, and then only update the things you need in order to modify the existing state of an application stack. So this kind of leads to the next thing, and I'm going to talk a lot more in detail about how this applies really to cloud-related things, are when we think about events, again, this is just the setters here. So really, we've just implemented getters and setters across multiple distros. In this case, we've determined that we specified that we should exist. But the reality is we actually don't exist, right? Which we queried with these basic getters that we implemented on our providers, where it's going to be the provider that Puppet determines is the one we need to use for a certain system, which causes us to actually call the setter, right? And a couple interesting things here is that everything in Puppet is viewed in terms of being a state transition, right? Because we know that the states were not the same, so we know that we actually make this setter call, which results in a state transition. Right, we have transitioned the state of this package from not being installed to being installed. And the last thing that I think is a really interesting characteristic of this basic model is something that we call no-op in Puppet, which is because I already know what things need to converge, it is reasonable to make estimates, and it's not perfect. And I'm happy to talk about the ways that it's not perfect, but we can at least make an estimate of these are the things that are out of sync. And I think that if we think of descriptions, let's say mutable descriptions of application stacks, where I find this most interesting is for things like autoscaling, right? To say that I have some feedback loop that makes determinations about the number of VMs that could exist. It'd be interesting to be able to run no-op and say, how many things did we say should be the current state of the application stack to get an understanding of how we might modify that given our current sensory inputs, which is something I think is fairly interesting. So the next thing that I'm going to talk about, which I think is really one of the most pervasive reasons that a lot of people are curious about applying what they know about Puppet to this next level in managing their infrastructure is really just because of the DSL. And I actually love this picture and this representation of it, right? If an individual resource is a building block, then right, the DSL is the actual Lego construction that we can make from that thing, right? It's about how do we compose those things, how do we combine them in various ways to create these higher level abstraction layers around things. So the Puppet DSL, it basically just composes collections of these resources, right? And sorry for people, again, I know I fall back into our crazy lingo and terminology. DSL is domain-specific language. It's really a fundamental thing about Puppet is that it's said to have its own language, which has some reasonable language constructs like conditionals and various things like that. But for the most part, it's just a way to build encapsulation layers around collections of resources. And this is a fairly typical example. I've commented most of the properties out of these resources, but here we can see I create a class, which is an abstraction layer that I can build around some collection of things, right? And in this case, it's fairly common to say package file service is a pretty general pattern in Puppet, right? For that we want to specify what it means to configure a certain application service in terms of its package, file, and service. And then we want to build this encapsulation layer around it so we can just refer to things as being web servers as opposed to having to worry about all the internal implementation details of, what's the actual described state of what it means to be a web server on the underlying system. And probably one other thing for people who are fairly new to Puppet that's worth noting is that you can also specify interfaces related to classes, right? So we could say web servers have characteristics themselves of, things like what's my bind address, what's my port, or maybe even what vhosts can be deployed into that web server. And at a very simplistic level, the reason that we build out this abstraction layer is so that we can refer to these things kind of in the abstract, right? Just give me a web server. What is that? Well, you can look inside of that class if you want to know. And when we go back if we can mentally go back to the first slide about Puppet's architecture in terms of make this thing a database versus make this thing a Tomcat server, this is kind of the level of that of we can think of nodes as being conceptually mapped to these roles, where those are expressed as a higher configuration level. And the last thing worth talking about is catalogs. Catalogs are this specification of resources which are description of state, which, as I talked about before, just map to these getters and setters that are used to understand how current state is related to this state and also how to achieve those state transitions as well. And this is a fairly simple catalog. I'm going to have an example when we look at application management of something much, much, much more complicated than this. But this is fairly simple to say that we actually have a package, we have a file, we have a service. Those things have dependencies between each other that, obviously you don't want to configure the file before the package because it's going to have to reconfigure itself in the next round. And one of the other things worth noting is that when we look at relationships between things, there's actually two kinds of relationships. One of those relationships is just a regular time-based order. This thing needs to be configured before this other thing. But another kind of relationship that we have is that we can refresh or respond to events from other things. And I think this is interesting at the application stack layer, which I'll talk about a little bit more. Because often you may just want to respond to change events from other elements whenever you're managing application stacks. And an example is that you might want to reconfigure a load balancer if there's a change to one of the web servers. Or you might want to reconfigure your web servers if there's a change to the database server. And the interesting thing about this refresh capability in Puppet, again going down to the Ruby level of implementing the providers, is that you can specify hooks for how things respond to events from each other, and then you specify how those events are chained through the resource elements in the Puppet DSL. So it's up to the developer or author of the providers to determine how you may respond to certain events. And then it's up to the actual author of the Puppet manifest to determine the relationships that are going to create those relationships between the resources that can cause those events. And it's always changed, right? That we may want to restart a service if a configuration file changes in this example. So the last reason, and another reason that we've kind of had a lot of interest in this general is text is awesome. And I think that's not a specifically, I guess, hard message to give to this crowd. Because there's a reason that so many people just love the terminal, love editing text files. And at least for my purposes and for the solutions that I built for various customers, it's just so easy to integrate text into workflows. It's so, just text plus version control is so unbelievably powerful, right? But you combine a Linux shell with version control with things built on text, and you can just, Linux is basically a system for integrating things together, and text is a fundamental building block of that, right? So text is awesome and amazing because now we can take these descriptions of things and not be confined by, poor APIs from vendors or not be confined by anything else. One other thing that's at least worth mentioning along this kind of text is awesome viewpoint is Puppet's also pretty modular, and everything being text-based makes it pretty easy to break things apart into various components, which again gives you a lot of flexibility for how you can integrate that into more complicated workflows. So I was going to break just for questions before we get into the next part of the presentation. So just general, like architectural / API fundamental Puppet stuff. Any questions before we move on?
If you do have questions, just wait for me to get there with the microphone so we can get on video as well.
We have one hand go up.
G'day, I just want one question about the getters and setters when you said, I think it was under the control aspects where you, I presume that's where you add and, you tell it how to add and remove, say, applications, processes and things like that. I gather you can rewrite your own for those as well?
Yeah, this is totally like if we look at Puppet itself and kind of types and providers that are implemented, those are relatively stable / slightly published APIs that are usable. So it's even possible to write those kind of extensions into modules that can just sit, kind of as user content on top of Puppet.
Okay.
And it gets a little bit hairy with environments, but I know that for people who know what I'm talking about, some of that stuff's being resolved, hopefully, as I speak here back in Portland, Oregon now. I know. Any other questions?
Does Puppet run in parallel when it does all this kind of configuration?
I'm going to talk about that when we get to limitations. That is... There's a slide on that. I have some interesting ideas about that, and I'm happy to talk about composing Puppet architecturally, talk about how you can implement something, but that is one of the critical questions that we're going to resolve in the next part. And any other questions? But I think what's interesting about that is if you think about this catalog or this graph-based data structure, graphs are actually pretty cool data structures for having a full understanding of how you can parallelize things. So I'm going to get to the next part, which is, I know that I've kind of touched on some of this stuff as we've gone through, but I'm going to focus on what might it look like for Puppet to move away from being node-centric and start thinking about Puppet for managing out actually application stacks or just infrastructure in general at a higher level. So the first thing that I'm going to start with is, we talk about ensuring consistency in a node-centric way by assigning these roles that are described in classes. And it's pretty clear for at least folks who have used Puppet before how that's possible. We're going to look at specifically, ensuring consistency against some infrastructure as a service endpoints for this example, which, I would say that this is the experimentation ground for at least trying out this concept is, all these infrastructure as a service APIs actually make it pretty reasonable to create and query for some reasonably complicated constructs that we can use. But clearly there's some things missing in Puppet, which we'll talk about as we kind of get through this. But we're going to start by just, we're going to ignore some of the harder questions and we're going to focus on some of the easy wins. Right, stuff that I think clearly makes sense, especially given the model that I just represented on Puppet, starting with just this basic specification of does the resource model actually map to the idea of application stacks, and what does that look like? So I'm awful because I probably should have put some reference to this. I've done a couple experiments with this, and I know that some community members have been working on some stuff as well. But I've written functional types against Google Compute Engine, partly because again I work for marketing. Here's Google Compute Engine. That's pretty sexy. Go. It was a task that I was given recently, and I've written ones against Amazon, which is probably what most people are interested in, especially given that there's now actually an Amazon Australia zone, which I know at least some people, maybe not so much in the open source world, are super excited about. But GCE at a high level, just like any other infrastructure as a service API, gives you reasonable APIs that implement the things we need, which are really just these fundamental getters and setters, right? We just need reasonable APIs for retrieving the state of things and for modifying or updating the various states of things. And if we look at something like GCE, and this is pretty typical across OpenStack, CloudStack, whatever, AWS, that we can specify VM instances. It's pretty different in terms of the flexibility that you're used to allow, that you can use to specify networks. GCE is actually pretty cool in that you can just say VLAN go, like attach instances to VLAN go. Also firewalls and also disks. And for me, for actually modeling application stacks, these are probably the fundamental building blocks of I need to be able to spawn virtual machine instances. Maybe for the more advanced use cases, probably not initially, it's nice to just be able to actually build out VLANs as well. Firewalls, general software rules for firewalls are usually what's used. in order to protect instances. And the last thing is, of course, persistent disks, right? Because in general, infrastructure as a service, disks are ephemeral by default. So just looking at an example of what something like GCE for building out application stacks as resources might look like, first is you may want to actually specify something called an application stack. And it's reasonable to say that this should be some kind of container. I can show an example that I have on my laptop in some directory somewhere for showing what kind of arguments might this take. One of the arguments is ensure, right? Maybe you want to apply some code artifact to build up stacks, and you want to apply some code artifact to tear down application stacks. So looking at this, a place you might want to start is you might want to build out VLANs. Here's an example of me building out some VLAN called Dan's network, right? I'm just specifying some gateway and some actual range for the VLAN. And this is all based on a prototype that I wrote that works. I mean, with GCE, we can pretty easily say, does this VLAN exist, given some project or user or however tenancy is built in it. One thing about this that I've noticed is that, so I talked before about properties. The flip side of that is parameters. And parameters are things that we can use to describe resources, but that we can't actually modify when that resource happens to exist. And the determination of properties versus parameters is really what's supported. Well, two main limitations. How lazy is your developer in terms of actually utilizing all the things that are supported, but also what's actually supported against the APIs. Can you query for things, and can you make modifications to existing things? I would like to think that the limitations that the only property here is ensure for these things, and I'd like to think that's because the APIs didn't support it and not that I'm fundamentally lazy, but it's possibly a combination of the two. So here as well, this is also me being ridiculously lazy and trying to save space because this is the long slide. I'm using this kind of weird relationship syntax to essentially make everything parse order the order it's going to run in. So these are creating relationships. It's more typical to create relationships with meta parameters or special parameters on a resource to say, I require this guy's first, I come before this guy, or notify and subscribe for actually specifying relationships. This is me just happily taking one line out. So it would fit a little bit more cleanly on the slides. But this is saying that these things must happen in this order. First, the VLAN has to occur. Oh, this is a bug. Interesting. This should clearly be that the network should be Dan's network, right? Because we're attaching the firewall to the network in this example. But again, we're specifying some firewall rules. Here's a rule we can apply to certain things to say that port 80 should be open for TCP, and it should be, of course, attached to the correct VLAN, which it isn't in this case. Oh, well. Oh, wow, and this as well. Maybe it's a slightly oversimplified example, but it also has support for specifying that we're going to attach a firewall rule to the instance, and also that the instance should clearly be attached to the correct VLAN as well. So this is a fairly succinct way to actually specify what an application stack may look like. A couple things here that are somewhat technical limitations, and I may, given time, I may actually go through and show a real example of this, but it should actually be a defined resource type and not a class, is one thing, right? Classes are singletons. You can only apply this once. A defined resource type allows you to parameterize things. So you can say, maybe this would be, Dan's server 1. Maybe the 1 would be the thing that we use to parameterize this set of things to make them unique. Right? Because we want to make sure that we're creating all these elements specific to the application and that we have a reasonable way to model that. I'll make sure that I go and show some examples of what this actually looks like. So this is a reasonable starting place, except it doesn't actually do anything yet, right? Like, so what? I created a VLAN and a firewall in an instance. What does it do? Well, it consumes money. It doesn't actually do anything else, right? Because all of these infrastructure components that we're specifying only really exist to be consumed by some application. So I'm going to talk a little bit about some of the stuff going on and what that looks like, but I think this is where I'm definitely going to start getting to some of the limitations and some of the either fundamental issues with Puppet as a framework for this and potential fixes for those things. So this, going back to my little kind of recursive Puppet logos, it's kind of 3 levels of Puppet, right? That we have this level that manages out the actual infrastructure, and then another layer where that maps back to Puppet for role assignment, right? Because traditionally, Puppet assigns roles. So if we look at one of these constructs of specification for managing and creating virtual machines, then if we want to use Puppet to assign roles to those things, then it's really a 2-step process. Step 1, we must either get content, right? We're describing content that describes what it means to be an application service or what it means to be a database. We need to either get that to the node or we need to get that to a master. And I'm going to talk about master versus masterless in context to this in a second. But let's say for the easiest case, we just need to ship that content down to the node. Right, and this is showing an example of, here we can specify what modules should actually be installed on that instance. And this integrates with something called the Puppet Forge. Oh, this is another one of this is actually the mascot that started it all, in my slightly inappropriate attempt to build my own mascots and branding for my company. But this is something that's been coming along a lot for us, which is the Puppet Forge. Who has modules on the Forge in here? Ouch. Who's using modules from the Forge? Okay. I should have raised my hand to the first one. I have tons of stuff up there.
Who's contributed to the Forge?
I have. Yeah. So this more or less is just mapping straight to the Forge backend, right? We have a combination of, and this is slightly inaccurate because a combination of user account plus module name is enough to determine how to at least get the latest version of something down. And I know that for my example, I actually support both getting modules from the Forge and also getting modules from Git, right? Because for development purposes, for forking purposes, for all of the realities of the way that we really interact with things. So the next thing we have to do is we need to actually specify how we're going to classify a given node. And this is, so classification, I showed these previous examples of how we can create these abstraction layers that are classes. This is how we fundamentally apply those to an individual node. And for those of you who have some, I guess, architectural familiarity with Puppet, it looks just like an ENC, or I guess if you use create resources, it looks like something that might be consumed by create resources. So the way that I've implemented this in kind of a couple ways, but if we look at just the Puppet apply model of distribute content down to each node, run Puppet apply, I just have a real basic ENC, which so this actually becomes metadata, which is generally supported by most infrastructure as a service systems, and then each node just gets that metadata down from a simple ENC that it uses for classification purposes. So this is the other part of that. And I think I have time to kind of go off the rails here a little bit. But there's one potential problem, like kind of mentally in this problem space, this is where I am, is I'm kind of at a point of, I'm not sure if I actually like this idea of combining or conflating provisioning with configuration. And the reason is they're actually two fundamentally different things, right? And if we think about ways that we could send refresh signals through the graph, I think that applies a lot more to the configuration as opposed to the provisioning aspects of things, right? I think in general that, provisioning, it's not the provisioning of something that means that something else needs to respond to it. It's generally the configuration of things. And I wanted to say at least one kind of crazy idea that I have, getting completely off the rails, is, so I actually have some other resources that need to be checked in and are kind of what I'm playing with these days. One is a Puppet Master resource, just for, make this thing a Puppet Master, which is all kind of hacky SSH underneath, which is, it's how we should all start. It's how we should start everything, right? And it's basic scripts for people who know Cloud Provisioner. I'm kind of taking that functionality and saying that I can say, I should show an example of that. I have some code examples I could show, but I basically have something that says machine, you can give it a reference, which it uses to determine how to connect to the machine, and then it'll make that machine a Puppet Master. And idempotency is actually kind of interesting in terms of, if you're specifying classification at this level, I at least have an idea of what idempotency might look like. For Puppet Master resource, it's pretty easy. Just like SSH out a little script that runs Puppet -- version or detects some port or verifies that it's running some certain version that you use to determine if you need to install that thing as a Puppet Master or not. The other idea that I had, which is slightly crazier, which I need to play with, is actually running Puppet in no-op to determine if you should run Puppet. Right, so I know, like I said, it's crazy. But this would actually give you, otherwise how could you have resources called Puppet Agent or Puppet Apply and expect and actually run those in no-op? It's crazy, just an idea. I know, just an idea. Don't try this at home.
I'm trying it at home.
This is when I put on my crazy white coat and maybe this one. But it's just a conceptually interesting idea of applying idempotence for configuration with Puppet. I'm just not sure how else you would do it except by running a Puppet no-op to make it make a determination of how many things need to apply, which of course has performance issues, right? It's almost like the same as how people make rsync idempotent, right? You have to basically run that pre-rsync to determine if something needs to be synchronized. So I'm going to talk just in general about some of the things that I think are awesome, and then I'm going to counter them with some of the things that are less than awesome, or as I like to call them, to-dos. It's my to-do list of things to fix. So I think this is one of the most, and I know that I've tried to cover some of this as I've gone through in order to make it relevant to a lot of the introduction and explanation that I've done around Puppet's architecture. But the first point in terms of general awesomeness is just this idea of having this composable configuration language, which is somewhat of a standard. Right? And I think standard is actually kind of a cool point around this. Abstraction layers for configuring out, there's a lot of stuff in the kind of platform as a service world. It's a whole new tool set to learn. It has its own set of limitations, and I think that if we can figure out how to map Puppet conceptually, or something that looks almost identical to Puppet conceptually to that model, then I think that admins, as they move from the node-centric versus infrastructure-centric layer, can take a lot of their domain knowledge with them. The other thing, again, when I talk about composable, and I know that I've heard I know that I've heard CloudFormations become a little bit more composable, but at least when I had to look at CloudFormation, it was that's kind of one of my inspirations. I actually really like CloudFormation, and I really think it has some great fundamental kind of architectural ideas, but it's a mess. It is absolutely a mess. It's not something that's easy to write. It's not something that's easy to consume. It's not something that's easy to share. The only way that I found that I could use it is I had to write my own templating tools in Ruby that sit on top of it and then build my own reasonable abstraction layer on top of it. Right? And I think, my reasonable, and I see someone smiling, you probably had to do the same thing, my reasonable abstraction layer is nowhere near as good as Puppet. Right? So why not just have Puppet be the thing that does that? So that's kind of my baseline of whatever I do should be better than CloudFormation, because that's really probably the standard of something that's similar in the industry right now. It's also something great that I have to make sure I fully architecturally understand it so that I can use, so I don't have to rethink the problem and I can use the stuff they have, which is cool. They actually have quite a few cool features. Kind of a little bit of review of just general awesome. I know that I talked about idempotency before, but if you think about class parameters, where maybe a class parameter is, number of virtual machines, you're using create resources to create those things dynamically. Sorry for people who don't know Puppet that well. But it'd be pretty darn easy to tie that into an ENC that ties into some alert system, right? So you can have data that specifies, scaling infrastructure that rebuilds catalogs, right? So the catalog would change with the number of machines that should be in the middle layer. And I think this is pretty cool in terms of idempotency, because right now, you could just run and just add the things that you need. Right? You can understand the things that are already there, add the things you need, and even have event-based reporting for understanding what those differences are. One other thing that I think is kind of cool for this, but I don't really know. If you look at a lot of the other tools that are out there, you have to handle failures, right? And how do people traditionally handle failures? You have some kind of queue with some event processing that can figure it out. Potentially, you could rerun and actually understand as opposed to ignoring failures. To say I run once, I run twice, I can actually see in Puppet maybe how many failures there were. I would hopefully see them in the first run, and then hopefully I can run a second time, and it'll just build out the things that are missing. No-op, I think I already covered. I mean, especially when you're looking at auto-scaling or potential feedback errors. Oh no. So I'm going to very, very, very quickly get to the unknowns. Is this done as in 5 minutes? Oh. Yeah, as we mentioned, parallel processing of catalogs has to be solved, especially as you're provisioning virtual machines out. There's this whole need for a system for how do we actually serve as a proxy node? Like, what's the role of the machine that's actually interacting with the endpoints? How do we manage credentials? Where does that live? This is unsolved in Puppet land. Also, application stacks are persistent, and there's no CFN what application stacks exist. There's no way to query for that right now. So there needs to be this whole other idea of persistency built into Puppet to understand what application stacks already exist. It's unclear to me how that fits in the model. Master versus masterless, I'll just sum it up and say masterless is so much easier. I know master has a lot of features for centralized management, but at least for getting started, it's so much easier just to push content and run Puppet apply. Sorry that my limitations part was unnecessarily condensed. Do we have time for questions, or I got to get out of here?
Yeah, we do. Yes, we've got 5 minutes left.
Oh, I couldn't.
They're telling me no, we don't have 5 minutes left.
I'll be in the hall if people want to ask questions. Sorry for my...
We've got 3 minutes, okay.
Oh.
We do have time for some questions.
Yeah. Quick time for questions.
Hi there, this is a super quick question. You've mentioned you can extend Puppet using Ruby. Can you only use Ruby, or can you use any language which runs on a Puppet-supported system?
In general, and according to documentation, Ruby is the only thing that's supported. Puppet also operates through data structures, so it is possible to consume data structures in other languages. But in general, it's probably more effort than it's worth. It's a Ruby ecosystem.
Thank you.
Well, you can use Puppet to apply your changes to the machine. Can you revert back the changes that you've applied in a...
I mean, honestly, I've worked with customers to build systems like that. It's crazy. I strongly recommend against that. And I think that fundamentally, if you have a model where that's a necessity, I would look at limiting that model. Limiting the needs for that model. Any other questions? Oh, awesome. I'll be on the hall afterwards if people have more questions. Okay. Thank you, everyone.
Thanks for LCA 2013 and Linux Australia, a small gift.
Awesome. Thank you.
Thank you.